Alright, so here we have a problem that has to do kind of indirectly with waves. This is really just about using velocity. So a car travels at 60 miles per hour, that's what mph is, for 2 hours. We want to know how far the car has traveled in miles. So we want a distance, x. We know that velocity is distance over time. Should be delta x over delta t, and that's our delta x, our change in distance. So if we solve this for delta x, we're going to multiply both sides by delta t, and that's going to give us d times v to delta x over delta t times delta t, and then these are just going to cancel. So we will get delta x, I'm just flipping this way, is equal to v delta t. So our change in x is our velocity multiplied by our time. Velocity is 60 miles per hour, and we're multiplying that by 2 hours. If our time was in a different unit, like if we had said our time was in minutes, we'd have to convert the time to be in the same unit as, so that the hours would cancel in the velocity. That works. And then we have 120 miles. Oops. So the distance that the car has traveled, delta x, is 120 miles. Part B is how far is that in meters. So this is just a unit conversion. So we have our distance in miles, we have a conversion from miles to meters, and we're just going to find delta x in meters is going to be delta x in miles multiplied by this conversion. And we're going to put it so that meters is on top. This way our miles cancel. So if we write this out with our numbers, we have 120 miles multiplied by 1609 meters for every mile. Our miles cancel, and this is, just check, 20 times 193,080 meters. So that is our distance in meters. This is our distance in miles. All right. Part C is what is the car's velocity in meters per second. So here, we already figured out we have our mile to meter conversion, and we have that 1 hour is equal to, let's do 60 minutes, and 1 minute is 60 seconds. Let's just do that. So we can set this up. So our velocity in meters per second, we're going to have our velocity in miles per hour, which is 60 miles in 1 hour, and we're going to multiply that by, so we're going to multiply this here, we're going to change that into meters, the top part, so that's 1 mile for 1609 meters, and that's going to give us, that's this conversion. And then we've got the hours, and we need to change that into seconds. So we've got 1 hour, and we know 1 hour is 60 minutes, so we can put our 60 minutes here. And we know 1 minute is 60 seconds. So this would do our full conversion, and we can check that all of our units, except for meters per second, cancel. So miles cancel, hours cancels, and minutes cancels. We're left with seconds and meters. So this is going to be, we've got 16 multiplied by 1609. We're going to divide that by 60, and then we divide it by 60 again. And it is, we've got 26.8 meters per second is our velocity. All right, so now we have part D. We're saying that the car speeds up and it's now going to travel at 80 miles per hour for 100 miles. And we want to know the time that the car has been driving, so this whole time. So we've essentially got a time, a T1, and that's for this first part where it's traveling at 60 miles per hour for 2 hours. That's our T1, we need to find that. We're going to need to find our T2, which is how long it's been traveling for 80 miles per hour for 100 miles. How long did that take? And then we've got our T total, and that's just going to be T1 plus T2. Alright, so for the T1, what is this? We have B equals, oh wait, we have that one. That was, right, that's given to us right here, 2 hours. That is 2 hours. And let's put this in seconds, even though they didn't ask for it. So we've got 1 hour is 60 minutes. 1 minute is 60 seconds. Just to check, minutes cancel, hours cancel. And that's going to be 2 times 60 times 60, which is 7,200 seconds. And then let's find our, it's going to go here. T2 is 80 mile per hour for 100 miles. So here we can use V equals delta X over delta T. If we solve this for delta T, we're going to multiply both sides by delta T. That's going to give us that. And now we're going to divide by V to give us delta T by itself. So we're going to use this to find T2. So it's delta X over V. So delta X is 100 miles. Always include your units. And our V is 80 miles in 1 hour. This is, so our miles are going to cancel. Hours is going to come up here on top. And we've got 100 divided by 80 is 1.25 hours, if we want that in seconds. 60 minutes. Those cancel. And we're going to be left with 4,500 seconds. That's going to go here. And then T total is just these added together. So which is going to be and that's kind of an awkward number in seconds. So we could have kept all of these in our hours, right? Then we would have taken the 2 hours and the 1.25 hours and said it's 3.25 hours.